In this video, we are going to solve example 3.6 that is taken from chapter number 3, Mechanical Properties of Material, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement is an aluminum specimen shown in figure 3-26 has a diameter of 25 millimeter and gauge length of 250 millimeter. If force of 165 kilonewton elongates the gauge length by 1.20 millimeter, determine the modulus of elasticity, and also determine by how much force causes the diameter of specimen to contract. Take modulus of elasticity. A modulus of rigidity of aluminum is 26 gigapascal and yield stress is 440 megapascal. So you can see this is a tensile test specimen for aluminum. This is the gauge length, which is L0 and given as 250 millimeter. The diameter of this specimen or gauge length is D0, which is equal to 25 millimeter, and 165 kilonewton load is applied. So due to this load, there is elongation in this gauge length, and this change in length, for example, this change in elongation is equal to 1.20 meter. So you have to determine the modulus of elasticity, and due to this load, the length will increase but diameter will contract. So you under this load, how much this diameter contracts. So we have to determine that contraction as well. So let's start with the solution. So first thing is that we have to find the modulus of elasticity, and we know that modulus of elasticity is represented as E, and this is as we know that by Hooke's law, stress is equal to modulus of elasticity into strain. So E is equal to stress over strain. So first we will find this normal stress. So normal stress due to this force of 165 kilonewton will be equal to force which is F over A. So F is 165 kilonewton. So 165 into 10 raised to power 3 Newton. And the diameter of this is given as 25 millimeter. So diameter area of cross-sectional area of this circular cross-section will be equal to pi by 4 d square. So pi by 4 and d is 25 millimeter. So in meter it is 0.025 square. So when you solve this, you will get stress will be normal stress will be equal to 336.1 megapascal. Now we'll find this. We have find out this. We will find strain. So we know that strain is equal to change in length over original length. So change in length is this one 1.20 millimeter. So I will write 1.20 millimeter divided by original length, which is 250 millimeter. So 250 millimeter. So when you solve this, you will get 0.00480, and it will be either dimensionless or you can also write as millimeter per millimeter. Clear? Now we have both these values, so put it in this equation. E is equal to stress over strain. So E is 336.1 into 10 raised to power 6 Pascal divided by strain is 0.00480. So when you solve this, you will get 70 gigapascal. So this is the answer of our first part. Now we'll move towards second part, in which we will see that due to this load of 155 kilonewton, there will be how much contraction is in this original diameter D0. So we'll move toward that contraction of diameter. Now we will find this contraction of diameter by using this equation that we know that Poisson ratio is equal to lateral strain over longitudinal strain. So we have this longitudinal strain, but we do not have lateral strain. So how we'll find this? We also know that there is an equation relationship between modulus of elasticity Eg, which is modulus of rigidity, and Poisson ratio nu. So what is this equation? This equation is G is equal to E over 2 divided E divided by 2 into 1 plus nu. Clear? We have all this value. You can see G and G is given, E we have find out 70 gigapascal, so we'll find this nu. So G is 26 gigapascal, so I will write 26 gigapascal. E is 70 gigapascal, divide by 2 into 1 plus nu. Clear? And from here you will get this 2 into 1 plus nu is equal to 70 gigapascal divided by 26 gigapascal, and 2 plus 2 nu is equal to 70 divided by 26. So we are interested to find out nu. So 2 nu will be equal to 70 divided by 26 minus 2, and if you divide 2 on both sides, so you will get Poisson ratio, and it will be equal to 70 divided by 26 minus 2. Clear? And when you calculate it, you will get this Poisson ratio comes out to be 0.347. Now you have this value, you can just plug it in this, so we will get the lateral strain. So we will, from here we know that lateral strain will be equal to minus nu times longitudinal strain. Longitudinal strain is the strain along the length of the specimen. So minus 0.347 multiplied by longitudinal strain is this one, which is 0.00480. And when you solve this, you will get this lateral strain will be equal to minus 0.00166 millimeter per millimeter. Now this lateral strain is perpendicular to the longitudinal strain. So longitudinal strain will be in this direction and lateral strain will be in this direction, which is causing to contract the diameter. Now what we will do is that we will find the contraction in diameter. So contraction of diameter is, therefore we know that lateral strain is equal to change in diameter, which is delta D divided by original diameter D naught. So this change in diameter or contraction is equal to lateral strain multiplied by D naught. So minus 0.00166 multiplied by 25 millimeter will give you minus 0.0416 millimeter. So this minus sign means that there is a contraction of 0.0416 millimeter in diameter. So the diameter will contract by this amount. Clear? Which is the answer of our this second part. And that was all about this example problem 3-6. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.